Hi everybody, this is Dr. Dadu presenting Advanced Probability Theory 3. Well, this is the third and final video on the subject matter, which is simulation in distribution. The version that I've worked with is version 4.2.0 of R. And then the packages that I have installed in it to be able to do this video is Simplex Reg and New Distributions, spelled like this. Okay. There are PDFs. The PDFs attached to these packages are the reference materials. Now, simulation means different things to different people. If an engineer is talking, this is the simulation he has in mind, general simulation. When a statistician is talking and mentions simulation, this is what he means. Now, the model to an engineer is a prototype, the one they call simulators. Well, there are packages for them as well, e.g. MATLAB can be used to handle their work. Well, that's why there are Simulinks in MATLAB. Okay, but if we take models to be probability distributions, then these two are synonymous. Because what we do in statistical simulation is to supply some random numbers to a probability distribution and ask it to work on them and give results. Okay, that's essentially what we do. Now, statistical simulation and R, some distributions are inbuilt in R already, irrespective of the version of R you have with you. An example is the uniform distribution. To use it, to ask how to generate uniformly distributed values, just give this command, R uniform, run if 1001. What this means is give me 10 uniformly distributed values. The list A value is 0, B value is 1. You remember my talk on uniform distribution. Okay, if it is normal that you want, then R norm. This is the syntax. This is an example. Give me 10 normally distributed with mean 0 and variance, standard deviation 1. If it is better, this is the syntax. Well, give me 10 better distributed values. The shape values, there are two shape parameters. At default, it is 1, 1 in R. No, now, the non-central parameter is 0 in this example. But if you are using it, you obviously know your shape parameters may not be 1, 1. The non-central parameter may not be 0. Whatever it is, you put there. And the number of values you want, simulated, you put it here. For the gamma distribution, this is the syntax. An example is this. But notice something here. In the example, I have those two values, the number of simulated values, then 1, which is the default for shape. The others, I didn't put anything, but R will know and put the default values there. So if you have a distribution in mind and you want R to advise you as to how you use it to simulate, put down question mark, then type R and type the first 4 or 5 letters of the name of that distribution. Open a bracket and close the bracket, then hit the enter button. See, in case of uniform norm, it's first 4 letters, but in this case of gamma, it is first 5 letters. Okay, once you do that, R will take you to where you can get information with respect to that particular distribution. If it doesn't do so, it's either you are not connected or that distribution you are talking about is relatively new and it's not inbuilt in R yet. Okay. Simplex distribution was built later. So it wasn't built with uniform, normal, gamma, beta. It was newer, I mean, it came newer than those ones. And by typing R simplex, open bracket, what have you, it will take you here. But you see, since it has a particular package of its own, you will need to install that package. When you install the package, there's a PDF file that comes with it. Read that, you know how to handle. But essentially, this is how you use it to simulate. This is the syntax for simulation, and this is an example here for you. This is a case of getting 10 values from it with mean 55 and variance 16, where standard deviation will be 4. Okay. Now, there's another package in R, newly written. Its name is new distributions. Wow. New distributions is very, very useful in the sense that it covers very, very many new distributions. Look at Marshall-Hawkins G distribution. The list is very, very long. Exponential Poisson G distribution. It's a very, very lengthy list. They've been handled and kept in new distributions, spelled like this. Okay, if for instance you want to use beta extended distribution to simulate, this is the syntax. Well, an example is that you want 10 values. These are the scale and shape parameters. At default, they will be 1 anyway. If it's anything different from 1, put whatever you want it to be. Put it there. And that will be it. All right. Now, what if the distribution is entirely new? It is not in any of those ones that I've explained. You can still work on it. R allows you to do so. Well, how will you do that? R gives you the opportunity of writing the function yourself. Okay. So, for this demonstration, I would ask R to supply me with any 400 random numbers. And I will put a function here and pass the 400 numbers through this function and ask R to be plotting the result, so that we'll have a pictorial representation of the output. Okay. This is the code. The function that I have written is numbers that will request for 400 randomly generated values. It will pass you through. This is actually the part of the function that does the simulation. And as it works, it will be plotting the result. It will be plotting the results, and at the end of the day, this will result. This is the result of the simulated value plotted for you to see it pictorially. Well, that's the farthest I intend to go on the issue. I mean, simulation and distributions now. Please like, share, and subscribe. Bye for now. Thanks for listening. See you next time when I come up with another part of statistics.